in Excel. If he told you a different way that's easier, that's totally fine, whatever works best for you. Also, if you can think of any other way for you to put this material together and have it make more sense to you, again, perfectly fine. It doesn't have to look the way mine looks. It's just what made most sense to me to show you guys, okay? Alright, so Simpson's diversity index, that's just a really complicated equation for taking proportions of total organisms, okay? So right now what we're going to do is look at our slow-moving stream, and we want to know the proportion, so the number of organisms of each species over the total number of organisms in the entire stream, okay? So all you have to do here is look at your data sheet, and you can go just do our little handy-dandy sum tool, and sum your entire rows of individuals, and that will give you the sum. Makes sense, right? So this is how many individuals you saw of the amphipods, of the water pennies, of the leeches, total out of the entire habitat, okay? Then what we want to do is have an overall total, which again, all you have to do is sum, but sum the entire column. So now we have, for each individual species, how many individuals we saw, but we also have the total number of individuals of all species, okay? Do pay attention to, at the top, it says if you score amphipods, water fleas, etc., using the few, some, many, tons, crawling with them type measurement, then go ahead and just convert these to 5, 10, 15 respectively, okay? So that's the way, if you have abundant, just say 15, okay? Just for conversion purposes. Even though it's probably a lot more than 15. Oh, wait. Okay. So now what we want to do is we want to keep doing our Simpson's diversity index, but this is another way to just kind of break up the pieces so you don't have to put in a giant equation that gets really confusing. So now what I want to do is I want to do little n, which is the number of individuals of each species, over big N, which is the total number of individuals, right? And then you want to square it. Don't ask me why you square it, you just do, okay? So now all you have to do is put this in your equation. So now we have the total number of amphipods over the total number of organisms all over the place for the entire habitat, and then we square it. These dollar signs, don't let these dollar signs worry you. All that's doing, if you put the dollar signs in there, is when you pull this down for the rest of these, that's going to keep this field on this cell. So you don't actually have to do that, but then you're going to have to keep moving this cell back up. But these dollar signs, nifty little Excel trick if you ever need it, that's where you can put them so that you keep this column straight and the row straight. So it's always going to reference this cell if you've got the dollar signs there, okay? Makes sense? It's just a nifty little trick in Excel that allows you to kind of freeze that particular cell, so when you're pulling stuff down, pulling stuff over, it's still referencing the correct cell. Okay? Questions? Okay. So now that we have that, you'll see that our Simpson's diversity index is D equals 1 over the sum of all the proportions squared, right? So now that we've got our proportions squared, we just want the sum of this column. So that's going to give us our denominator for our Simpson's index. Okay? That's all you have to do. And then finally, we want our D, which is just going to be 1 over the sum of all the proportions squared. We good so far? Excellent. Okay, so now we've got our D for our slow-moving stream. So this is the D for our habitat, slow-moving stream. So 4.6033, that's right here. Now you need to do the D for all of your habitats. So for the stagnant pond and the fast-moving stream. And for just whatever purposes, the yellow just means I made up those numbers. So I did the microhabitats next, but you'll have to do this for all of those, okay? So for the microhabitat, all I did was I took this group and pulled it down separately, and then you just do the same thing with the sums and the same equation setup, and then, but you're just isolating that particular microhabitat. Does that make sense? So then you have the same thing, your D for the microhabitat is 3.5217, put that in here, you do that for the rest of the microhabitats, and then you're done for that part. So again, you do this for all of your habitats, all your microhabitats, and then your stream, what you're going to want to do is you're going to want to combine all of your data from the slow-moving stream, the fast-moving stream, and the stagnant pond. So try to line up. It helps in your raw data sheets to highlight, and I'll show you a little of that in just a second. Highlight in different colors or give different icons so you can pay attention to species that you have in multiple microhabitats and multiple habitats, and that way you can just line them all up like so. But then you'll just have slow-moving stream, fast-moving stream, and then stagnant pond, but then you can still do the sum of all the rows. Does that make sense? So you're just going to be combining all of your individual data together and then just doing the sum of the rows and doing the equations the same way. And that's how you're going to get your stream D. Okay? So we've got habitat, microhabitats, and then stream. Make sense? Any questions? You guys have glazed over.